Hi everyone. Sorry I can't be there in person. I actually go to Tallinn every now and then. My wife is from Estonia, so maybe next time. So I'll just switch over to my slides and so you can look at the interesting stuff instead. I'll try to zoom in whenever we're going on code and stuff. So just shout or if you can't read what I'm showing. So there. That one is okay.
Yes, it's good. I'm going to mute our microphone so it's better.
That's no problem. Anyway, so the title of this session, talk I gave it in London, is Fast, User-Friendly and Power-Efficient Network Communication on Android. It's probably the longest title I ever had on a presentation before. But basically, I'm going to summarize my experiences and what I've seen from people when they do networking on Android and the common errors people do and how they should do it instead. So, yeah, moving on. So, this all comes down to three different things that the users want. They want the battery to last as long as possible. They don't want to use too much data traffic because it costs money and, well, it's not that nice for them. And also, they want the apps to be fast, responsive. Now, being fast and responsive is a very subjective thing, so we're gonna look at that at the end. So I divided this presentation into two parts, what the developers can do and what the UI designers can do. So we start with what developers can do. And it's always good to summarize stuff in three parts, so there are three parts that you should look at here. The first one is the HTTP client handling. How do you do HTTP calls on Android? Second part is how do you do background I/O. Well, as you probably all know, you shouldn't do it on your main thread, and you get a warning if you do it now, even an error. And finally, can you reduce the amount of garbage collecting that happens, because that is a very common cause for bad user experience. And all of these are things that I still see today in new code written that people are doing wrong. So hopefully you can get some new stuff from this. So we start with the most basic, which HTTP client should you use? And this is actually one of the most controversial things, because people tend to use the old Apache HTTP client, and that was the right thing to do in Eclair and in Frojo. That's quite a long time back today. Now, today you should only use HTTP URL connection or HTTPS URL connection. This is the only one that Google is working on, and it has better performance and improves speed and save battery, etc., etc. There's also a bunch of features built into this one that you can use, and I'll show you next. So, if you're not using HTTP URL connection but are still on the Apache HTTP client, make sure you switch. Now, one thing that's often people miss is that they don't use buffering. Very common thing, they just read straight from the input stream that they receive. So always wrap your streams with buffered input stream or buffered output stream. That is a very common mistake there. The only case you shouldn't do this is when you do bulk reading. And bulk reading is okay if you have small amount of data, but if you do the bulk reading yourself, etc. But usually most users will wrap this. Now, this is probably the most common error. This is how you do when you read the streams. So this is copied from the Java doc for the HTTP URL class. Since it does gzip compression in the background, it's not visible for the developer, you can't rely on get content length when it tells you how many bytes actually are received in the end. So you need to read the stream until it's exhausted, which means that you need to call read until it returns -1. Now, if you're reading like a JSON object or a bitmap, there are ready-made classes that handles this for you, but if you're reading the data yourself, I'm going to show an example, you should always read until it returns -1. Now, Google, I think this is, might be too small to see. I'll zoom in a little bit. Google recommendation, they have this in their code. Can you see the code there? Is that okay?
Yes, now it's okay.
Okay. So this is actually copied from the Google, the Android developer site, showing how to read a stream. I guess you can spot the errors here. So, for instance, oops. Yeah. So, for instance, you have a character buffer being allocated with a fixed length here. And as we saw before from the Java doc, you can't really rely on get content length, which means that you can't really detect how big the data is. So we can ask ourselves, where do we get that from? So, and also you do read here just once, not read until it returns -1. So Google's own recommendation is not perfect either. So let's move on to see how you really should do it. Now, this is small, so I will zoom in again. Is that okay?
Yep.
Now, what you do start with here is you define a buffer size that is big enough to fit most use cases. It's okay if it's too small, it's okay if it's too big. Just make sure that you have a fixed buffer size. In this case, we're going to read an input stream to a string. You create a buffer that you will read into, and then you create a string builder which we will use to define this string that we end up with. We also define the size for these two the same way. Now, if you go to the actual method implementation, we start by clearing the string builder that we have because we're reusing the same object. The reason we're reusing it is that we don't want to cause unnecessary garbage collection. And then we create the input stream, and we define the variable chars read, and then we read until we get -1. This is I've seen so many cases where you do this the wrong way, and so I think this is an important lesson for everyone. And unless you actually do it pretty much this way when you're going to read the stream, you're probably doing networking wrong in that way. Also remember to close the stream in a finally block, because if you get an exception, you still want to be able to close the stream. Okay. Going back to the next one. Caching. Now, Google has built-in HTTP file cache in the HTTP URL connection class. So this piece of code is just copied from what they have on their Android developer site. You create a 10 megabyte file cache for your application, and you install it, and it will all be taken care of in the background. This works from Gingerbread and on, and this method is also safe to use in the older versions, because otherwise, if it's not there, it will just not be enabled. So this is very good because it will take care of HTTP caching automatically for you. Posting data. There's a second mistake people are often doing here. They forget to set fixed length stream mode or set chunk stream mode, and then you will exhaust the garbage collector. Basically, you might run out of heap space or increased latency. So when are you going to use which one here? The set fixed length streaming mode is when you have a fixed, you know exactly how much data you have, and it's not data, it's usually a smaller amount of data. You don't use this if you're going to transmit a 2 gigabyte file or, well, even a 1 megabyte file. You just do it for smaller data blocks. Set chunk streaming mode is better for large files. So this needs to be called when you're posting data. Now, Another mistake people are doing is how they don't handle the connections properly. One thing is that you always need to close everything. Close the input streams, close the output streams, disconnect the HTTP URL connection object. That is important. But also, if you're doing only one single request at a time, one single request and then it might take 15 minutes until you do the next one, then you don't really need to have keep alive on your HTTP client. It's unnecessarily, it will just keep the connection open longer, it will drain more battery than necessary. Then you can call the system set property before you create the HTTP URL connection objects. That will be taken care of. So, the HTTP client, summarizing it, use the HTTP URL connection object. You need to remember to use buffer streams. You should always exhaust your streams when reading and enable the built-in caching. Remember to do set fixed length streaming mode or set chunk streaming mode when you're posting data, and disconnect and close properly when you're done. That's the first part there for the developers. Background I/O. This is a little bit more trickier, and some things here you've probably used before. I'm going to show one piece of code that most people have not used before. Now the trick when doing background I/O is to think asynchronously. You post something to the framework telling it to do some background operation, and you don't know when it will return something. For those that are web developers, you are used to do this when you use the XML HTTP requests. Pretty much the same methodology you should use here. And of course, no I/O should happen on the main or UI thread. That's natural for most developers, but I still see people missing this one. The good thing is that everything is already available in Android. You don't need to write a new framework for doing all of this. And finally, avoid creating your own thread objects. You don't need that. It's unnecessary, and then you need to take care of closing down the threads, etc., etc. Now, the Google recommendation is to use the async task. Async task is okay. Did I zoom in on the code there?
Let's see. Back.
There.
Yeah.
Now,
That's good.
so the async task is very good for small, simple things. Now this example I've written here is probably useful if you're doing just retrieve one single image or something. However, there are some drawbacks with this one. So, first of all, it's not reusable. So you need to create a new instance every time you need to do network. Sorry. Also, it's designed for short operations, a few seconds. So if you're doing a lot of big transfer or something, or several network calls, you shouldn't really use this one. And finally, it must be loaded and started from the UI thread, which means that it's not so easy to use this in the background in an efficient way, because it needs to be launched from the foreground. Now, the first way is to use intent service. The intent service is very good. It's a simple solution for a single threaded message queue. Very good if you want to queue a single task in the background. The drawback here is that every time the operation that you trigger is done, the service will stop. So it will cause some extra latency in starting and stopping this intent service. And that might be something you want to avoid. Now, another way to do it, is to use a handler. The handler object is very powerful tool. It allows you to do much more fine-grained control of everything. It's more flexible than intent service, also more complicated, and it allows you to do delayed scheduling. And you don't need to create any new objects in the allocation, so it's very nice for the garbage collector. An example of how you use this is basically the same thing as the intent service does, It's just to show you how the code should look like. A real life example would be more complicated, of course. This is a service very basic service. In the onCreate method, we create a new handler thread. We start the handler thread, and then we create a handler object which we get this handler thread. You will then have a handler object that runs on its own thread. That is taken care of by Android. This is a special type of thread which basically implements a message queue. Now, in the onStart command, we just get the intent that we were started with, and we post a message to the handler with the data that we receive from the intent. That's the first part. Next part here. The handle message method that is implemented by the interface that we implemented is just the callback for when the message is received by the handler. Now, in the onDestroy method for this service, you also make sure that you quit this handler thread. You get the looper and you call quit on it, and that will end the message queue. Now, quitting is, you can't stop a thread object, so this is the reason why you shouldn't use a thread object yourself, because then you need to take care of that synchronization and everything by yourself. And since Android have this ready-made for you, it's well, if it's free, it's nice, you know. Okay. Now, background data. Another thing to think about here is if you should do background polling from your application at regular intervals, or if you should rely on a push service like Google Cloud Messaging. Now, I usually ask myself these 3 questions when I do something like that. First of all, is new data available every 15 minutes or less? If it's available more often than that, then think of, do you need to notify the user right away? Can the user wait 15 minutes or more before he gets the data? And also, do you really need to notify the user? Because if you notify the user, you need to wake up the screen and everything, and that drains more battery. So maybe it's okay to just retrieve the data, and maybe it's okay to retrieve the data once an hour. So depending on your needs, you should choose either Google Cloud Messaging, or you use the alarm manager to do set in exec repeating. I'll zoom in on the code there so you can see what it looks like. The alarm manager, you retrieve the system service, you define the intent that's going to trigger your background operation, and then you call alarm manager set in exec repeating, and give it all the parameters. Now, set in exec repeating, what basically it will do, it will every 15 minutes, or depending on which interval you choose, it will send an intent to those applications that has registered for this event. So, which means that all applications that use this set in exec repeating, they will be triggered simultaneously, which means that we won't have network operations happening outside these intervals. It will be every 15 minutes, but nothing in between, when the phone is suspended, basically. And this is very good. If all applications would be doing this, you will have a much longer battery time. Unfortunately, most applications don't use any of this method. And they might get notifications very, very frequently. So that is a big reason why we drain the battery in the phone so quickly. Now, so this printout here, I'm guessing most of you have seen that one from the $VM GC explicit. And now, if you get this very frequently, then something is wrong. Then you are doing allocations unnecessarily. And it's usually very, very hard to find these things. So this checklist is basically following. Are you calling new inside a loop or in a recursive call? And you will be surprised, people don't expect that an object that they create new on would generate so much garbage collection calls. But for instance, the point class, which basically just contains two double values, if you call that one for frequently enough, your garbage collector will just exhaust your everything, and your UI will be very sluggish. So it doesn't really need to be a big object, but if there's any new allocation in a loop, then you will have a problem. Also, another problem is that people allocate large objects that are only used once. Like the example I showed where we use a string builder. Now, if the string builder would be allocated for every time you call this, then it will be garbage collected every time, and you will have a sluggish UI whenever you do network operation. Also, two small sizes for string builder or array list, which are typically two classes that many people use. Always remember to allocate these objects with a large enough initial size. Now, okay, so I've talked about what developers can do. So let's look at the UI designers. What can UI designers do, and what should they think about when they design the apps? This is also relevant for developers, of course, because not all developers have a UI designer by their side all the time. So, three things: application startup. How do you handle that one? And how do you show that progress, like a network download or something? And how do you handle that one properly? And how do you handle network errors? Two examples. Instagram and Facebook. Facebook shows a big splash screen. Now, this splash screen can remain there for quite some time if your network is slow, or if your device is slow for other reasons. Why do you show a splash screen? There is no real reason for showing a splash screen. The user knows they started Facebook. Instagram does it perfectly. Everything is launched and you can click on the buttons right away, even if there is no data shown. Another thing that people often miss was the UI designers and developers. So how do you handle and interrupt the startups? Have you ever launched the application and then immediately pressed home because it was taking so long, and then you start the application again and thinking that it will start up faster? Very common way of interacting with applications. Now, your application should be transparent to this. If the user presses the home button right after they have launched the application, you shouldn't abort everything and stop all network connections. Finish what you started always. This is also the reason why we do all the network operations on a separate thread, preferably on a separate service. This will also prevent that we call network operations too often, because every network call is very, very expensive. Show controls as soon as possible. Also very, everybody should realize that you don't really need to show a splash screen if you think about it. You should always give instant access to the user controls. Instagram does this very good. You launch Instagram, you can take a picture right away, you don't need to wait for it to load data. The progress indicator is very unintrusive, it's just shown there as a little thing that's rotating. You know that it's loading data, but it doesn't really matter for you if you just want to take a picture fast. Yeah. Handle network failures in a graceful way. Actually, here both Facebook and Google Plus does it good. Even if network fails, you still have access to the controls. I would say that Google Plus does it even better because you can scroll the data that you already have there. But a typical thing that you can see in some applications is that you pop up a dialog saying network error. Okay. That is not a good thing to do. The user, if there is only one choice, why do you show a dialog? There is no point of it. So instead, just show the data like they do in Google Plus. Much better. The user won't be so angry if something fails. They can accept that there is a network error, and it didn't stop them from just reading the post they already had downloaded. So, presentations go much faster when you do them over Google Hangouts, but I hope that I went through this in a way that you found something new. So, please, if there is any questions.
Yeah.
And,
I think, can you hear us?
yes.
Yeah. Do you have any questions regarding the network connectivity on Android?
I have.
Yeah.
What JDK version does Android use? Because I can't use Java 1.7. You told about the stream closing. It does automatically in 1.7 if I put in the try parentheses this input stream. What about the Android? Do you know?
Sorry, was it about which Java version, or?
Yeah.
I'm not sure I got it.
JDK.
Yeah, the question was about using Java 1.7, and it should do the
automatically close the streams.
Yeah, automatically close the streams, and
yes, Java 7 is not recommended to use when you're compiling your Android applications. Java, the Java SE from Oracle is not the same thing as you're running on Android. No. It's completely different things. You should use Java 1.6 or Java 6 when you're compiling your Android applications. You can't rely on the Java doc from Oracle on what that does. So automatically closing stuff that is documented in the Java SE documentation, it doesn't apply to Android right away.
Yeah, but do you know when will there be these features for the Android, like in Java 1.7?
No, that's I doubt that they will follow the path that Oracle is taking, because I'm pretty sure that they will go their own way. They won't. You will probably not see Java 7 in Android, or Java 8 for that matter.
Okay.
Thanks.
So, any more questions? Yeah, great insights on the. I found the part where you need to decide between push and pull. Been building that sort of apps before, and building up the cloud device messaging or Google Cloud Messaging APIs is a lot of boilerplate. So if you can think about it in before, if you even need it, you can not do a lot of boilerplate in that sense.
Yeah, exactly. So, think about the use case. Does the user really need the data? Is it necessary that they get it immediately, or can they just retrieve it themselves by pressing a refresh, for instance? If that is good enough, and then you should probably use that method instead.
Yeah. Okay, Erik, thank you very much for your time and for giving the presentation. It was really interesting. Next time you're in Estonia, then please let us know. So
I'll make sure of that. I'll keep you posted. So thank you very much. It was fun. Okay.
All right.
Thanks. See you.
Thanks. See you.
Bye.
Also, Erik sent me his slides, so I'll try to upload them somewhere and post the link on the Google Sites page. So you'll have the access to the high quality code also. Before the pause, we have a couple of t-shirts that we need to give out. So